Hello everyone, welcome to the next lecture on the numerical linear algebra. We will see that today's concept is Gauss-Legendre Quadrature rule. Myself Dr. Harish Garg, you can follow and subscribe my YouTube channel. Now, what we have discussed so far, we have learned the concept of how you can find the approximate value of the integrations from xn to xn. Can you tell me how you can find the approximate value by using the numerical methods? Yes, you can use either as a trapezoidal rule or you can use as a Simpson rule, or we call as a Newton-cotes formula. Fine. For more detail about this, you can find my playlist Numerical Linear Algebra, and you can watch about the composite trapezoidal rule, error analysis, Simpson 1/3 rule, and many more lecture available in this playlist. Make sure students, in this Newton-cotes formula, what you did is we have the x0 to xn. We have divided this interval into the equal parts. That means the distance between them is my h. The same distance we can define as the x2, that is again h, and so on. Fine. So that means the points are equispaced. All those xi's, these xi's are called as a node, and each node is my equidistance from the initial. x0 to x is h, x1 h, where h you can define as upper limit minus lower limit divided by number of the intervals. For example, if you are using the trapezoidal rule, then we can define as h by 2 function values at the point x0 plus function value at the point xn. Similarly, for the Simpson 1/3 rule, we can define by using this equation. Make sure students, these are the only trapezoidal and the Simpson rule. But if you look about the formula of the composite, trapezoidal rule, you can watch this lecture, composite trapezoidal rule and the composite Simpson 1/3 rule. Make sure in the simple trapezoidal rule, the value of the h, that will be my xn minus x0 divided by n. In the simple trapezoidal rule and the Simpson 1/3 rule, n is my 1. However, in the case of the composite trapezoidal rule, n must be greater than 1. The same in detail we have discussed and learned in the last 3 lectures. You can watch and learn the concept. Now, in general, you can write the Newton-cotes formula is lambda 1 f of x0, that is the first value, plus lambda 2 function values at the x1. How you can write the x1? Which is very simple, x0 plus h. How you can write the x2? That is the x0 plus 2h. How you can find the xn? This is x0 plus nh. Or in general, we can say it is a lambda I f of xi. Fine. Now plus error. But if you closely look about this case, the value of each of the xi's, x0 plus h, x0 plus 2h, all are known to us, while the value of the lambda I is unknown to us. Fine. And our target is to find this unknown value, that is called as a weighting coefficient in the case of the Newton-cotes formula. But what are the limitations of this Newton-cotes formula? So as we can see, we have divided the intervals, we have divided the domain, that is x0 to xn, into n number of the equally spaced components. Fine. So, but as we have divided the number of the strips with the size h, but once we can reduce the value of the h, or once we can reduce the number of the strips, then the function evaluation will be less, definitely, and that will impact on the accuracy of the approximate solution of the function. So to address such kind of the limitations, we will learn the concept of the Gauss-Legendre formula. The formula is similar. You can write as a integration from a to b is lambda I f of xi. The major difference here is the value of the xi are unknown, while in the case of the Newton-cotes formula, the value of the xi, that is the node, are known to us. What is the basic difference between them? For example, if I consider the two integrations 0 to 1, a of f0 plus and so on. Fine. While in the second case, we can consider a of f of x0 plus b f of x1 and so on. Now you can see the value of the 0, 0.3 and 1 all are known to us. And how many unknown values are there? In this, you can see the value of the A, value of the B, value of the C. They are my unknown. And these are basically my weight vectors. That's the coefficient of the function. So that's why we can solve this problem by using the Newton's cotes method. Because only the weighting vector, this is called as a weight vector. Okay, you can see the weight coefficients. Only the weight coefficients are unknown to us. On the other hand, if you look about that, the weight coefficients A, B and C, these are my weight coefficients. Fine. But the points node, what is the value of the x node, x1 and x2? They are also unknown to us. Therefore, this integration we can solve with the help of the Gauss-Legendre Quadrature rule. Fine. Now, so the Gauss quadrature rule is integration from A to B, where the values of the weight vectors and the positions, or called as the node, are always unknown to us. And our target in this Gauss-Legendre quadrature formula is find the value of the lambda I and find the value of the xi. This is our target throughout the lecture. In the numerical analysis, the endpoints, if we consider the endpoints, the Gauss quadrature formula is defined by Carl Friedrich Gauss, and it basically find the exact result only for the polynomials. That means you can find the value of the f like of a0 plus a1x plus a0 a2x square and so on. So our target is to find how you can find the approximate value of the integrations. This is our target, to find the approximate value. We can approximate the values with the help of polynomials. We can approximate the functions with the help of the polynomial of degree 2n minus 1, at the most 2n minus 1. But the most important thing here is the domain. The integration, instead of the a to b, my function, domain of the integration must be -1 to +1. But don't worry, I will tell you also what will happen if you want to integrate from 1 to 2 fx. This is not -1 to 1. But firstly, I will tell you what will happen if my domain is from -1 to +1. Once your domain is from -1 to 1, then you can apply the Gauss-Legendre Quadrature rule by using the equation number 1. And our target is to find the value of lambda I and xi. But students, make sure that this rule is called as Gauss-Legendre Quadrature rule, or sometime it is only called as quadrature rule, or sometime it is called as Gauss quadrature rule. Fine. Now, what will happen? As I mentioned you, is well applicable only for the domain from -1 to +1. And my target is to find the value of lambda I and the xi always. But what will happen if my domain is, instead of the -1 to +1, it's from 1 to 3, or in general it is from a to b fx? How you can solve, how you can apply the Gauss-Legendre Quadrature formula on the function evaluations integration from a to b fx? It's a very simple. Our target is we can convert the integration from a to b to -1 to +1. And once we can convert them, definitely we will use the substitution. Fine. We have to make a substitution in such a way the function value fx and the function value fu both have the same area. That means if you draw the graph of the y is equal to fx and y is equal to f of u, the area 1 and area 2 must have the same representation. And how we can transform? By using the substitution. So I can assume the linear substitution is x is au plus b. I can assume the substitution is x is equal to au plus b. Now clearly say from this figure, whenever x is equal to a, u is equal to -1. That means I can say the function value at the point a is my -1, and the function value or the x value at the point b is my +1. I can substitute both the value in the equation number 1. So that means x is a, u is equal to minus 1. Fine. And in this case, it's a b, which is a plus b. Can you find the value of the a and b? So if you add them, you will get b is equal to small b plus a over 2. And if you subtract them, you will get b minus a divided by 2. Fine. So I can substitute the value of the a and b in equation number 1. So therefore, you can transform any of the integrations a to b to minus 1 to plus 1 by using the substitution. Upper limit, b is my upper limit, minus lower limit divided by 2 of u and so on. I will tell you with the help of the example. You can see, convert the domain, integral domain minus 2 to 2 of e raised to power minus x by 2. What is my a? A is my lower limit, upper limit is my 2, and my target is to convert minus 1 to plus 1. I can use the substitution b minus a. Fine. I can substitute the value b minus a 4 over 2, b plus a 0. So that means x is equal to 2 into u. Fine. Now we need a dx also. So what is the value of the dx? Dx is my twice of du. I can substitute the value in the given equation. That means integration is from minus 1 to plus 1. E raised to power x is my 2u, x by u into twice of du. So that will be 2 will be outside, minus 1 to 1, e raised to power minus u and du. And now once the integration is from minus 1 to plus 1, then you can apply the Gauss-Legendre Quadrature formula. Fine. Look at the second one. Again, a is my 0, b is equal to pi over 2. My target is to convert from minus 1 to plus 1. Now, how you can apply that? I can use the formula. X is b minus a over 2 into u plus b plus a over 2. So I can substitute the value. What is the b? B is my pi over 2 minus 0. It's a pi over 4 plus pi over 4. So therefore, dx will be pi over 4 into du. I can substitute both the values. I will be minus 1 to plus 1. Sine of x, x will be pi over 4 into u plus pi over 4 into du. So pi over 4 I can take is outside, into du is the required integration from minus 1 to plus 1. Now, what are the various types of the Gauss-Legendre quadrature formula? As we have seen, the Gauss-Legendre formula is applicable from minus 1 to plus 1 based on the nature of this value of the n. If you choose n is 1, you can choose n is 2, you can choose n is 3, and so on. Once you can choose n is 1, then we call as the one point Gauss-Legendre quadrature formula. Fine. If you choose n is 2, then we call as the 2 point Gauss-Legendre quadrature formula. If you take an n is 3, then we call as a 3 point Gauss quadrature Legendre form. Fine. Now tell me, I will tell you in detail what is a 1 point, 2 point and 3 point. So firstly, what is a 1 point? By taking n is equal to 1. Fine. So the equation becomes minus 1 to 1 fx dx. If you take an n is 1, then the expression becomes lambda 1 f of x1. Fine. So my target is, what is your target? Your target is to find the value of the lambda 1 and x1. Is it okay? Again, always remember, I will tell you the one easiest way to how you can find the value of xi. Make sure whatever the value of the xi you have obtained, the sum of the xi must be 0. Whatever the value of the xi is, whatever the value of the xi you have obtained. For example, if you take n is 2, then the expression becomes lambda 1 x2, lambda 1 x1, lambda 2 x2, such that the sum of the xi's must be 0. That is, what is the meaning of that? X1 plus x2 will be 0. Fine. Now in this case, you have only one xi, so that means x1 must be 0. Fine. And we will derive it. We will derive it whether it's a 0 or not. ये तो मैंने आपको इसलिए बता दिया so that once you can compute the value of the xi, you must remember to check whether your answer is correct or wrong. Now what is the quadrature rule? We have to approximate it by the polynomial. How many unknown coefficients are there? How many unknown coefficients? You have two unknown coefficients. Find lambda and x. So we can take the polynomial of with the two unknown variables like a0 plus a1x. You have the two unknown coefficients. Fine. Or you can take it as, these are called as the coefficients of the a0 or called as bases. Fine. So I can substitute f of x is equal to 1 and f of x is equal to x in the equation number 1. So you will get integration from -1 to 1 into dx. It will be lambda 1 of 1. Similarly, for the second case, it is 1 to -1 x into dx. It is lambda 1. What is the f of x1? It is x1. Now you can solve this value. The left hand side integration is 2 is lambda 1. That is x square by 2 is a 1 by 2 minus 1 by 2 is 0. Lambda 1 into x1. So this implies lambda 1 is my 2. Fine. And lambda 1 x1 is 0. So since lambda 1 is my 2, which implies x1 is my 0. So as you can see, as I told you, x1 will be 0. Therefore, I can substitute both the values in the equation number 1. You will get the 1 point Gauss quadrature formula is twice f of 0. I will explain you with the help of the two numerical examples. The first example is you can apply the Gauss quadrature formula on the limits -1 to +1, and in this case the limit is from a to b. So in this case your target is to firstly convert the limit from -1 to +1. Anyhow, look at the first example. What is the formula for the 1 point quadrature formula? So what is the value of the fx? Because the integration is from -1 to 1, so fx is my directly. Fine. So now you can substitute the value twice 0 by 2. So e raised to power 0 is 1. 2 is the right answer of the problem by using 1 point Gauss quadrature formula. In this case, the limit is not from -1 to 1. So we can use the substitution. Fine. So how you can solve them? We can use the substitution. X is b minus a over 2 into u plus b plus a over 2. So what is the b by 2 is u and 1. Fine. So therefore dx will be my du. So I can write as I is from -1 to +1. X, what is the value of the x is? U plus 1 e raised to power u plus 1. Dx will be du. Fine. Now the limits are from -1 to +1. So by using 1 point Gauss quadrature formula, your integration is twice of f of 0, and in this case f is my this part. This is my f of u. Now if you substitute f of 0, it is a 0 plus 1 e raised to power 0 plus 1. Answer will be twice of e is the right answer. Similarly, we can learn the concept of the 2 point quadrature. In this case, I can take an n is my 2. Once you can take n is 2, your equation becomes lambda 1 f of x1, lambda 2 f of x2. How many unknown parameters? How many unknown parameters? You can see there are the 4 unknown parameters. Once there are the 4 unknown parameters, you can choose the value of the fx with the 4 unknown coefficients. a0 plus a2x square plus a3x cube. So 4 coefficients are there. Or you can choose fx is coefficient of the a0, coefficient of the a1, coefficient of the a2, coefficient of the a3. So I can choose the fx is 1x, x square and x cube. I can substitute the value of the fx in the equation number 1. The left hand side becomes minus 1 to 1, 1 of dx. Again, as I mentioned you, the sum of the xi's must be 0. So that means x1 plus x2 must be 0. Fine. So that is the way you can check your answer in the examinations. Now, if you substitute, it will be lambda 1 plus lambda 2. Similarly, if you substitute in the second equations, fx is x, it's a x into dx. It will be lambda 1 x1 plus lambda 2 x2. Whenever fx is x square, the left hand side becomes x square. The right hand side becomes, what is the f of x1 is x1 square, and second number is x2 square. Similarly, for the third component, you can write it. Fine. So now can you solve this part? On the left hand side, it is my 2. This part is sum. Fine. Can you solve this integration? It is x square by 2 from minus 1 to 1. It's a half minus half, 0. 0 is lambda 1 x1 plus lambda 2 x2. Similarly, for the third part, you can solve. It's a 2 over 3. It is lambda 1 x1 square, and for the fourth part is a 0, and so on. Fine. Now you have 4 unknowns and the 4 equations. So after solving, you will get the value of lambda 0, lambda 1 is 1, and you can see the sum of the x1 and x2 must be 0. Fine. But the question arises is how we can solve these equations. I will tell you the full derivation in our next lecture, because otherwise this lecture will be the very long lecture. So I will tell you the full derivation in our next lecture very easily. So finally, once you know the value of the lambda naught, x1 and x2, I can substitute the values in this given equations. Lambda 1 and lambda 2 are my 1. F of x1 and f of x2 is the required Gauss 2-point Gauss quadrature formula. Similarly, I can explain you with the help of the one numerical example. Now in this case, you can see the limits are already minus 1 to 1. If the limits are from a to b, then we firstly convert from the minus 1 to 1. Now you can compute by using the 2-point Gauss quadrature formula. What is the Gauss quadrature formula? F of minus 1 by root 3 plus f of 1 by root 3. Because the limits are already from minus 1 to 1, what is my fx? Fx is 1 over 1 plus x square. Fine. So I can substitute the value. It is 1 over 1 plus x square. It's a 1 over 3 plus 1 over 1 plus 3. So that will be 3 over 4 plus 3 over 4. That will be 6 over 8. That will be, 6 over 4. Fine. 6 over 4 means 3 by 2. That means 1.5 is the required answer of the problem. Look at the 3-point formula. In this case, we can take an n is my 3. Fine. And the equation becomes here. How many unknown coefficients? There are the 6 unknown parameters. So we can choose the polynomial x1, x square, and then x5. Again, I can substitute all these value of the fx one by one in the equation number 1, and we can write the equation as here. Clearly say it will be 0. It is a 2 times lambda 1 plus lambda 2 plus lambda 3. It will be x integration of the 1 is 0, and so on. You can write the equation as this. Again, after solving these equations, you will get the value of the lambda 1, lambda 2, lambda 3, x1, x2, and x3. Fine. Again, once I will cover the 3-point quadrature rule, I will tell you the detailed derivation how you can solve them. Again, you can see the sum of the xi is my 0. Fine. So therefore, the 3-point Gauss quadrature formula is lambda 1 f of x1, lambda 2 f of x2, lambda 3 f of x3. Now the important points to be remembered. Fine. As I mentioned you how you can check your answer in the examinations. Sum of the xi must be 0. Fine. And sum of the lambda I must be 2. You can check your answers. You can see 5 over 9, 8 over 9, 5 over 9. If you add them, sum, you can see 18 over is a 2. Fine. If you look at the 2-point formula, you can see the lambda 1 is my 1, 1 plus 1 is 2. Fine. Similarly, if you look about the 1-point formula, what is the 1-point formula is? Only the 1 lambda, that's the lambda is my 2. Another important point that you have to remember while studying the Gauss quadrature rule, xi's are called as the nodes or called as the points or called as the positions, while lambda I are called as the weight vectors. The nodes are always symmetric about the middle point, as I tell you. Another way, if you not remember how you can derive these formulas, xi's are the roots of the Legendre polynomial. We all know the Legendre polynomial is 1 over 2 raised to power n factorial nth derivative of x square minus 1 raised to power n. Fine. So if you find the value of the p1, you can substitute n is equal to 1 and so on. You get p1, p2 and so on. How you can find the value of the xi? We can find the value of the xi's based on the p1, p2, p3. For example, once you are talking about the 1-point quadrature formula, that means n is 1. Once n is 1, p1 is equal to x. So can you find the roots of the p1? How you can find the roots? For finding the roots, we have to substitute 0. That means x will be 0. And you can see the value of the x is my 0. Fine. Similarly, for the 2-point quadrature formula, n is my 2, p2 is my 3x square minus 1. So can you find the roots? Roots is a 3x square minus 1 is 0, which implies x is plus minus 1 over root 3. And you can see x1 and x2 are the roots or called as a node of the 2-point quadrature formula. Similarly, for the 3-point quadrature formula, you have a p3. Can you find the roots? 5x cube, sorry, it's a 3. 3x cube minus 5x is a 3x cube. It's a 3x cube minus 5x. Fine. So once you can find that number will be root. Sorry, it's a sorry. It will be. It is a 5x cube. So I can take an x is common. That number will be 5x square minus 3 is 0. So the answer will be is a 0 and it's a plus minus root 3. 5x cube minus 3x. It's fine. It's a 5x cube minus 3x. Fine. So that is a typing error here. So exact way is 5x cube minus 3x is a 0. That will x is a common. X is a 0 and it's a plus minus root 3 by 5. You can see the value of the xi. Fine. So this is the overview about the Gauss-Legendre quadrature formula. I will tell you in details about the 2-point Gauss quadrature formula in our next lecture onwards and the various numerical examples as well. Till then, you can like, subscribe and comment on my videos. You can watch the numerical linear algebra playlist for the various other lectures related to the numerical linear algebra. Till then, you can share this video with your friends. You can like and comment on this. Thanks for the watching. Happy learning always.